Good afternoon, everybody. My name is Michael White. I sit at the IOCM group at the University of New Hampshire, Center for Coastal Ocean Mapping in New Hampshire. Today we're going to be talking about procedures and organization for coastal composite bathymetry projects. Essentially, as the IOCM Center, we're tasked with processing data. These data we're talking about today, these are specifically hydrographic surveys that are external to NOAA for the purpose of updating coastal hydrography. And this data originates from a variety of agencies using a range of acquisition systems. So for example, outside of NOAA, these may include Army Corps of Engineers, USGS, universities, other institutional data sets, and all these institutions and other agencies are using a range of acquisition systems such as multi-beam echo sounders, single beam echo sounders, and we also do some LiDAR work as well. The areas we're working in are coastal areas, and if you heard Pat's talk earlier before, these tend to be areas of lower priority to NOAA, i.e. they're not major shipping ports, they don't represent a lot of commercial traffic. However, these areas tend to be important either for recreational boaters, maybe some small commercial fisheries. Bottom line, these are areas, because they are low priority, they don't tend to be as the charts in these areas don't tend to be as updated as frequently compared to higher priority areas. So there is a need to crowdsource outside bathymetric data in order to bring to the chart or at least check for chart adequacy. Bottom line, our project today has led to this unique workflow allowing NOAA to ingest non-traditional data directly into the Marine Charting Division for chart comparison. If anybody has some time afterwards, I'd love to talk about two of our success stories from New York and New Jersey, South Shore of Long Island and some of the Back Bay and the coastal areas in New Jersey. We're currently looking for other areas. We're in talks with maybe the state of Massachusetts as well as the Channel Islands out in California. Those will be revealed maybe next year. What I'd like to do right now is walk through a workflow of what our data process looks like. First with our data ingestion, then formatting and converting, and then our deliverables. So first we have our data ingestion and categorization. These pretty much go straight into ArcGIS and the geodatabases along with our supporting metadata. Our first question we have to ask is who is the originating agency or organization for each survey? That's going to tell us a little bit about what equipment they're using, how accurate it is, what types of surveys we are expecting to see, and the file format. Like I said, the what, acquisition system, file formats, what horizontal or vertical datum they're working in, what units they're working in, are they creating grids, or are they just exporting ASCII or text files? And finally, where, geographically, where are these happening? We need to compare to the chart or these areas we're interested in, and we also have to look at depth. We do a quick overview just compare to the chart internally at IOCM to see, does this data look good, or maybe there's a deton we have to pick out immediately. So these are some examples from our New York Coastal Composite Bathymetry project. So agency name on your left, systems on the right. Stony Brook University, they run a multi-beam echo sounder, Simrad 3000, single beam echo sounder as well. Army Corps Engineers running their Seasmill LiDAR, single beam echo sounder. Town of Hempstead, again a single beam. USGS, again a single beam, and the Earl B as well. Our next step is formatting and conversion. We need to take all of these, we need to ingest them, and then we need to put them into a format that we can work with. First is file conversion organization. We take these XYZ points, whether they're CSVs, whether they're text files, whether they're Excel spreadsheets, we put them into point and table features into geodatabases. Now, why did we make the decision to use geodatabases? One, of course, for file management, easy to organize. Two, we'll always have those tables stored in a single location. And three, if we have to go back and reprocess these things, batch processing, converting the vertical datum, converting the horizontal datum, regridding them, they're right there for us, easy to do with some simple Python scripts or just ARC tools in the toolbox. Projection and conversion of units. We are told by Marine Charting Division, MCD, what they want, how they want it. We're like Burger King, you can do it your way. We're happy to do whatever they want. Currently, because of the areas we're working in, North American Datum 83, UTM 18 North, we always convert to mean low water. For the vertical conversion, we tend to use VDatum, which is a internal NOAA software, also available publicly, feet, and always depth direction positive down. All of us in the oceans, we live in a positive down world. Essentially, as the number gets bigger, you get deeper. Here are some of the examples of some ArcGIS tools and operations we've been using from our project. As you can see here, some of these are just basic projection and reprojection tools. We also can decimate grids with rasters if we have to regrid them at different resolutions, if we have to regrid point files. Sometimes we do some raster math in order to compare services. Let's say we have overlapping surveys from the same agency. We can do a depth comparison or volume comparison. Raster to point, export raster to different formats if they want different, maybe an ArcGrid over a GeoTIFF. Again, happy to help. And we also have a variety of formats, some examples listed here. One of the nice things about using ARC and using the geodatabases, it can intake a variety of formats, it can export a variety of formats, and especially if we're using some other hydrograph software, Fledermaus, QPS, maybe we're grading in Caris, a really nice tool to have. Finally, our deliverables, what we are handing off to MCD, we're giving them grids and rasters, either those grids and rasters that we took or we created using the IDW tool in ArcGIS or like a shallow biased gridding algorithm, say in Fledermaus, Caris. We're also giving them shapefiles of the coverage of the surveys so they know where these surveys are covering with the MQual tables. I'll address MQual in a minute. So you have some examples here. These are examples from Long Island South Shore. These are what these grids would look like. These are Stony Brook multi-beam grids. You can see not necessarily full coverage, but again, if we ask ourselves, well, hey, if these charts haven't been updated in a certain amount of time, and some of these soundings on these charts are for when people were actually using lead lines, and this is a low priority area, well, maybe the acquisition system or maybe the survey isn't internal to NOAA, but if it's better than what's on the chart, maybe we should be asking ourselves the question, is it worth updating the chart with these data? One would argue, well, probably. We want to have the safest charts out there for navigation, even just for recreational boaters. So absolutely. On your right, we have the coverage of these shapefiles. So we use like the raster domain tool to create coverages, again, using the geodatabases. And finally, there are MQual tables. These tables essentially tell NOAA internally, these are S57 attributes, how good these surveys are or the details about this survey. They contain the metadata. Most important part of these MQual tables, one might argue, is the CATSOC or the category zone of confidence. Essentially, on a ranking scale, how good is this survey? Is it 100% coverage with object detection versus all the way down, not so good? Bottom line, that will be used later in our composition process to when we put these surveys together, or at MCD when they decide what surveys to use over the other. And then, we join these two attribute tables, and we zip these files, and we send them right along. So, in summary, our center successfully has put together these workflows for the ingestion of hydrographic data outside of NOAA. Again, some success stories with New York and New Jersey. New Jersey is actually currently being updated. Some of those charts, I think they'll come out over the winter using some of this data that we've put together. Our group is also responsible for recommending best practices and documenting our SOPs. So if something's been done one way and we decide, or we might find that, this way is faster or provides a better product, we'll recommend it and of course document it. Like I said, we're looking to other areas. We might be moving up to New England or even ingesting some data sets from the California coast. And we're also looking to integrate some additional software tools. I had a great session yesterday with Mike Wilburn talking about ArcGIS for maritime bathymetry. I think that's something that would be really neat to put into our workflow. And with that, I will thank you, nice and fast. And if any questions, appreciate your time.